Okay, let's talk about asking empirical questions. Empirical questions are those that can be answered with information obtained from observation and experience. Some starting points for these questions are the way we ask any kind of question. Who, what, where, when, how, do, which. We have to be careful about why and should questions in empirical work, and I'll show you why that is. So first I want to say that there are really two levels of empirical questions. At the highest level, we use questions to guide research, or sometimes we use hypotheses to convey the overall aims of a study or a review or an empirical inquiry. So for example, an overarching guiding question could be, is income inequality related to human mortality or morbidity? That's the kind of question that's pretty high level of abstraction and will guide an empirical project. Then we have more concrete, specific questions that are asked as part of a research project. So for example, within the kind of study that I mentioned above, we might ask specific interview or survey questions about income or health issues in order to answer our larger question about the relationship between income inequality and mortality and morbidity. Should questions are non-empirical because the answers to these questions require value judgments. So anytime you see the word should in a question, it's not a good guiding question for empirical work. So for example, if we ask, should we use a certain intervention? Research alone cannot answer that question. It's not the kind of question that can be answered with empirical evidence alone, because the answers to that question will depend on our goals, our values and preferences, our skills, resources, and maybe on empirical evidence. So we avoid using should questions to guide research. Now, it's okay to use should in specific questions within a study. For example, when we're studying people's opinions. We might, in a survey of social workers, ask, do you think social workers should read research reports? And that's asking for an opinion. Why questions are better off when they're reframed for empirical work. So here's a real example. There's a study that was conducted that asked, why is crime so violent in South Africa? And I find this question very unclear. It could mean what factors are associated with violent crime in South Africa, or it could mean, has violent crime increased over time in South Africa, or is crime more violent in South Africa than in other sub-Saharan countries or elsewhere? Or maybe they mean, how do violent crimes in South Africa differ from violent crimes in other countries? Maybe they mean, is violent crime more common than nonviolent crime? Or what are the differences between violent and nonviolent crimes? Or what can we do to prevent violent crime in South Africa? Any of these questions are viable questions for research, but they're different questions. So the first question isn't at all clear. It's not clear what investigators want to know. Here's another example of a why question that will be better when it's reframed. So the question is, why are child maltreatment rates higher in some low-income countries than in other low-income countries? Well, this could mean at least two different things. It could mean what factors account for differences between country differences in child maltreatment rates. That's a good question. A better way to frame that same question would be to say, what country-level differences are associated with different rates of child maltreatment? What country characteristics are associated with different rates of child maltreatment? That's better. Now, another and completely different question would be, is child maltreatment a result of different causal pathways in different countries? It's a good question. A better way to ask that same question, because it's more specific, would be, are the factors associated with child maltreatment in some low-income countries different from the factors associated with child maltreatment in other low-income countries? Again, these are different questions. So here's some criteria for empirical questions. What makes for a good empirical question? Think of the acronym SAMPLE. It should be specific, it should be answerable, it should include measurable or observable constructs. In social work, we want practical questions that are relevant for policy, practice, or action. Should be logical, based on theory or a logic model. And it should be empirical. That means it could be answered with observable evidence. Empirical questions are specific. The question, does it work? And the question, what works? Are not good empirical questions, because it depends on what you mean by it and works. So let's take some non-empirical questions shown on the left and reframe them to create better empirical questions. So in the top left side, we have a question, does this treatment work? Well, this is not a good question because relevant problems and outcomes are not specified. Does the treatment work for what problem, in what ways? We don't know. Another reason why it's a poorly framed question is that it appears to call for a yes or no answer, and that's simply not realistic. Treatments don't work or not work. They might work for some people and not others. They might work under some conditions or in some settings and not others. So the answer to this question is likely to be maybe, but it depends on something else. So it's not a very good question. The third reason it's not a very good question is that it doesn't specify a comparison. Compared to what? So on the right, you see a better question. Is scared straight more effective than no treatment in reducing juvenile crime? Now, this is an empirical question because we've dealt with some of the problems that I identified earlier. We've specified an intervention, we've specified a problem and an outcome, juvenile crime, and we've said what we're going to compare it to, no treatment. What's the answer to this question, do you think? Well, the answer is no. Actually, scared straight is not more effective than no treatment. It's more likely to increase juvenile crime than doing absolutely nothing. Next question. What's the best treatment for some condition? Okay, well, the reason that that's a poorly framed question is that it requires knowledge of the universe of all possible treatments for this condition and knowledge of their effects. So that's simply not answerable. How could we know what are all the treatments for any given condition? Whether it's anxiety disorder or poverty, there are an infinite number of possible treatments. So we really need to specify the types of treatments of interest. So on the right, we have specified types of treatments. Here the question is DARE2, which is Drug Abuse Resistance Education version 2, more effective than the original DARE program in reducing illicit substance use among high school students? So now we've specified the interventions, the problem, the outcome, and the population. Great. I don't know the answer to this question. I haven't seen enough research on this. The question about the original, we know the original DARE program was not only not effective, but it actually had harmful effects. The original DARE program actually increased the likelihood of illicit substance use among high school students, exactly the opposite of its intended effects. So the lessons from these first two issues, Scared Straight and DARE, are that intervention and good intentions aren't always enough. Next question. How effective is motivational interviewing, a popular intervention? Again, it's not really specific because it doesn't say for what problems and population or compared to what. So let's fix that. And on the right, you see a better framed question. Is motivational interviewing more effective than 12-step programs for the treatment of substance abuse? Much better. What do you think the answer to this question might be? research I've seen suggests that they're about the same. Okay, your turn. In relation to social work, what are some should questions that you can think of, either questions that you would pose or that you've heard others ask? What are some why questions that you can think of? And how can we reframe these as empirical questions? Let's try this in class discussion. And here's another framework for doing this. Give us your non-empirical questions and what's wrong with these questions. And then how might we reframe those to make better empirical questions? Let's practice this in class. So again, empirical questions are answerable, and some questions cannot be answered because they're too vague. For example, the what works question or does it work? Too vague. And also, empirical questions should be posed so that multiple answers are possible, so that all potential answers are possible. And to do this, we need to avoid asking leading questions. So for example, if we ask, what do clients like about our program? That's really not the whole question. A better question is, what do clients like and dislike about our program? Multiple answers are possible. The first question really forecloses some answers. So empirical questions should be posed so that any answer is possible. And if you really don't want to obtain a particular answer to your question, you're probably not engaged in research or empirical inquiry. If you only want to know what clients like about a program, you might be involved in marketing exercises, and that's a fine activity, but it's not empirical work. Let's think about how we can deconstruct empirical questions to make them more useful. Empirical questions include key constructs. These are the main ideas in the question. And we're going to formulate empirical questions using the PICOS framework. So formulate an empirical question, and then let's ask, what are the relevant concepts in this question? What's the relevant population or problem? Is there an intervention or multiple interventions, and if so, what are they? Or maybe instead of interventions, you're interested in predictors, or we would call them independent variables. Are comparisons relevant in your question? And what are the relevant outcomes or dependent variables, criterion variables? Now, questions will have some, not necessarily all of these components, but these are useful components to look for in empirical questions. And there might be some other components or considerations. For example, we might pose some questions that only look at certain kinds of research or study designs. Or we might pose questions that are limited to certain geographic areas or certain points in time or time ranges or certain settings, maybe schools, clinics, communities. But again, what are the key components of your question, the key concepts in your question? So pose an empirical question and identify your key concepts or key constructs. Let's do this in class. Good constructs are measurable. So some studies use nominal and operational definitions to turn ideas, constructs, into variables and measures. And there are two steps in this process. We start with nominal definitions, which are like dictionary definitions in that they define terms in other words or synonyms. They shouldn't be circular. They should really explain a term. For any given construct, multiple nominal definitions are possible. So there are many ways to define a particular term. For example, economic inequality could refer to differences in income or to differences in wealth. Those are two different ways to think about the idea of inequality. And then operational definitions take it one step further to indicate how a construct will be measured in a particular study. And again, there's no single right way to do this, but this process turns a construct or an idea into a variable, again, by specifying how it will be measured, how we'll know this phenomenon when we see it. Again, there are multiple ways of doing this. So for example, there are multiple measures of depression, clinical depression, including the Beck Depression Inventory, the Hamilton Rating Scale, and others. And each of these tools really operationally defines depression in somewhat different ways. But they're all getting at the same underlying construct. We should think about how theory and observations are related. So in this diagram, which I find enormously useful, theories are sort of the top level, the highest level of abstraction. They're ideas, actually sets of ideas that are linked to each other in very complex and hopefully useful ways. And then at the bottom of the wheel, we have concrete observations, things that can be observed in the world. And these things are connected, or could be connected, in a number of ways. So we could begin with theory, and based on some theory, create a logical deduction. If this theory is true, then we should see certain evidence of it in the world. And this could lead us to creating a hypothesis about relationships between variables. And then we could study that hypothesis by interpreting it, nominally defining and operationally defining the key constructs, developing instruments and scales to measure them, taking samples, and then observing data, collecting data, measuring results, and estimating parameters or characteristics of a population, making generalizations back to a larger population, and then I'm going up the left side to formulating concepts and propositions, and perhaps supporting or refuting a theoretical construct. Or we could start at the bottom with observations, and based on observations in a setting, begin to collect data, do it with some rigor and some systematic process, generate empirical conclusions, and develop or formulate concepts based on that data to create theory. So when we go from theory to observation, we're engaged in deductive reasoning, moving from ideas to observations. When we go from observation to theory, we're involved in inductive reasoning. And in reality, we can and do start anywhere in this wheel, and we can wind up anywhere else. That this is the scientific process that connects theory and observation. And in the middle, you see that hypotheses and generalizations can be connected by tests of hypotheses and decision rules, decisions to accept or reject hypotheses, that then through logic are used to support or refute certain aspects of theories. So this may be a little more than we need right now, but it's a good illustration of how theory and observation relate. We'll come back to this at several points in the semester. Those bottom-up approaches, beginning with observation and moving to develop theory, the inductive studies, actually create constructs from observations instead of using a priori or top-down measures. We'll come back to that too, that's important. But in the top-down deductive reasoning mode, we are formulating hypotheses, sometimes as an alternative to empirical questions. So we could use hypotheses to guide researcher reviews, and it's important to say that there are several different types of hypotheses that can be used here. They are directional or non-directional, and then hypotheses are also associational, predictive, or causal. Let's have a closer look at these differences. So what are the differences between directional and non-directional hypotheses? A non-directional hypothesis suggests that two variables are related, but it doesn't say how. So for example, if I say income inequality is related to health outcomes, it's a very general assertion of a relationship, but no indication of what happens when one increases, will the other increase or decrease. A directional hypothesis specifies how changes in one variable are associated with changes in another. That is, what direction does this go in? So, for example, if I say greater income inequality is related to worse health outcomes, I've shown the direction that I expect to find. Hypotheses also could be correlational, predictive, or causal. So a correlational hypothesis just says that changes in one variable, let's call it x, are associated, they correlate with changes in another variable. But it says nothing about which comes first or cause and effect. A prediction specifies time order. So an increase in x predicts comes before a change or increase in y. So x predicts y. We've specified time order. And a causal hypothesis takes this one step further, and it says that increases in one variable x actually cause an increase in y. So notice that there is a hierarchical relationship among these hypotheses. That is, a causal hypothesis assumes that the cause predicts the effect and that the two variables are correlated. So cause involves all three things: association, prediction, and cause and effect. A prediction assumes that the variables are correlated and it adds time order. Correlation is the simplest type of hypothesis in this scheme because it's only saying that two things are related. No time order, no cause and effect. So here are some topics for empirical questions. We can ask questions about concepts and categories. So we do this when we're thinking about assessment, what kind of condition or what type of disorder, anxiety disorder, is appropriate in this case. What's the diagnosis? What's the condition? So these kinds of these phenomenon and these kinds of empirical questions really are investigating ideas or conditions in and of themselves. Another large topic for empirical questions has to do with rates and trends. And now we're interested in, the incidence and prevalence, how often something occurs, how common it is in a population or several populations, how things may differ over time across settings, or across subgroups. Other topics have to do with associations, as we've seen, and talking about different kinds of hypotheses. That is, what are the relationships between variables? Or we can ask questions about predictors and prognosis. Often questions about risk and protective factors fall into this category. And there are a number of different topics for empirical work on causes and effects. So we're interested, for example, in the etiology or causes of various conditions, health and mental health problems, social conditions. Cause and effect also come into play when we ask questions about the effectiveness of interventions. We're thinking of interventions as causes and outcomes as effects. So when we ask about impacts or the relative or comparative effectiveness of different interventions, those are questions that imply cause and effect. Similarly, questions about cost effectiveness or cost-benefit analysis are based on assumptions about cause and effect, so they fall in this category. Then we can also ask questions about generalizability or applications from one sample or site to another. And we may ask questions about research methods and measures, like what's the reliability or validity of a particular measure or a certain kind of study design. So here's a worksheet that I'd like us to talk about in class, where I've asked you to identify some assertions or beliefs that you have about a client or social problem, about rates, trends of that problem or condition, some correlates or risk or protective factors, relevant interventions, and intervention effects. So let's talk about what we think we know, how we think we know it, how certain we are about this knowledge, and what questions you have. This is just a way to explore issues that you care about and different kinds of empirical questions about that topic. I've said before, but I want to say again, that in inference, is a conclusion based on logic and evidence. There are different types of inference, and they require different types of logic and evidence. And this goes back to these topics of inquiry that I mentioned before. So we can make inferences about constructs and categories. For instance, when we talk about the meanings of certain constructs, when I say, to me, clinical depression means, and then I provide you with a nominal or operational definition, I'm making an inference about what that construct is. Inferences help us with understanding, maybe underlying dimensions or components of a concept. And we also often use typologies or different types to illustrate variations in a condition. We make inferences about rates and trends when we talk about the incidence or prevalence of a condition, or again, differences over time, place, and subgroups. We make inferences about relationships between variables, about predictors, about cause and effect, and about generalizability. Now, here I'm connecting different topics or types of inferences with the logic and evidentiary requirements needed to support those inferences. And this graphic really is a roadmap for this entire course in one slide. So let's spend a little time on this. If I'm making an inference or investigating a construct or a set of categories, I'm going to need reliable and valid measures, or what's called thick description in naturalistic inquiry, a good, qualitative, in-depth inquiry about a phenomenon. I need some kind of credible measure. And notice that that's the starting point for all other types of research and types of inferences. We always need that. Okay? So whether you're doing moving from theory to observation or from observation to theory, we need good measures or thick description of the main constructs of interest. Then if we move to looking at rates or trends, again, we must begin with good concepts and measures, but now we're going to need to add some form of counting or ratios or proportions or scales. So this does imply some kind of quantification to get at rates and trends over time. When we're looking at associations between variables, how two or more variables co-vary, we need some kind of way to measure that. And now we're into statistics, measures of associations that we'll talk about later. And we need what's called statistical power, or the ability to detect a relationship if it is there. We'll talk about that much later. Don't worry about it now. For predictions, we need all of the above: good measures or thick description, some kind of quantification, some measure of association, and time order. We need to know that the predictor comes before the outcome. Inferences about cause and effect are the most difficult to establish because we need everything I've talked about so far, and we need some theory of change, some reason to believe that one thing causes another, and we need the ability to rule out other plausible explanations for this supposed cause and effect. And then finally, when we're making generalizations from one sample or study or setting to another, again, we must have sort of reliable measures or thick description. The other requirements really depend on the kinds of generalizations that we're making. So if we were making a generalization about a rate and trend, then yes, we would need counts, ratios, proportions, or scales. But if we're just making a generalization about a construct, we would not. But far over on the right, if we're making a generalization about anything, we're going to need a basis for generalizing. And that comes either from using probability sampling methods, which we'll talk about much later, and inferential statistics, again, later, or some theory of, or reasoning for saying that I'm generalizing from one case to another because these two are, we say, proximally similar. They're close to each other. They're close enough to make an inference that one thing applies to another. Okay, we're going to spend a lot of time deconstructing these ideas, but that's the overview of this course. Thanks. Talk to you soon.